All right, let's begin. Welcome back to the Twitch stream. I really appreciate you hanging out with me this Monday evening. It's much appreciated. Some exciting times here in the land of nothing ever works. But hey, you know that's how it goes. YouTube viewers, yeah, you'll know what I mean. Our last video, things didn't go quite as good as we wanted them to. Stepper motor's doing that weird skipping thing, like it's missing steps. Don't know 100% where that exact problem's coming from. I have an idea. Well, I mean, I do know. It's not the motor. I changed out the motor. I tied in another one, same problem. It has something to do with the task that's created to actually set this up as a task. If something's causing it to block or delay or something, so I got to look more into how the actual tasks work. Because if we can remove the tasks, so we go here. So I basically just kind of commented out the tasks. I'm rebuilding it. All right. Now let's see if this phone wants to act up. I turned off Gemini, so it shouldn't be angry at me anymore if I accidentally touch stuff. So I got that. Let me flash this. All right. We do this. Let's go switch over to the phone. Hello. Come on. Oh, I changed a few things. I gotta get all right. All right. There we are. Yes, my wall of workbench. Don't you dare. Stupid phone. Stupid phone. Oh. Yeah, I can't even accidentally brush up against something on the screen while I'm doing this before it wants to freak out. All right, so the motor, we've already flashed. Now we've got a nice smooth operation of the task is enabled. So I'll have to look more into that, how tasks work. And right now this is kind of a deciding line of what we want to do. So I was looking more into it, and there might be an alternative way to drive the motor using another feature within the ESP32. Let me see if I can pull it up here. Using the remote control peripheral. And it doesn't even use the LED-C or and it's non-blocking. So we can have it do stuff and it won't block. So it might actually effectively work within a task. So I've kind of started setting up some code to modify to kind of remove the LED-C stuff and give that code a try, because we're supposed to be able to get even more control over it. And mind you, this is what Copilot .h. Okay, so it's actually a driver that's there. Okay. All right. So a lot of that stuff won't matter, but I'm not touching anything right yet. We're going to leave it all there. We'll just delete the stuff that we don't need for this. Fine. channel 0. All right. So let's see here. Configure the GPIOs, so we don't need the lead C stuff. Delete. So configures that. So we'll just get rid of all of this. Okay, that's not even handled in a while loop. All right, so let's do some. All right, what's our stepper pin? Stepper step. So and I don't even think we set that up either. Direction pin, yeah. Just like the LEDC driver, the remote driver handles all of that. Driver install. So here's where we're going to define a pulse pattern. Well, it looks like we can set multiple pulse patterns. And I don't know, we might have to look into it, but we might be able to make these like variables that we can change. They may not have to be constants. So we might be able to do this, but it looks like we can actually tell it how many steps we want it to go. So let's build this guy and see if it wants to. Okay, so there is RMTRX.h. That's fine. The driver's appreciated. It should still work for now. Let's see what happens. We may not use this for this because it's going to take a little bit too much to code. But I just want to test this because this might be something we will flesh out over the course of moving forward with this. And of course it doesn't want to do anything. So it may be so depreciated it doesn't want to do anything. Make sure. Well, hi. Hi, little kitty. Another one of my cats came down to say hi. Oh, no, it should be on the stepper step. And it doesn't say I have to actually doesn't say I have to actually enable. Oh, wait a minute. I think I know what I did wrong. The same thing I did the last time. Well, hi. Hi. I think I forgot to actually enable it with the logic here. Not surprising. Because honestly, if we could use this driver, maybe we'll spend some time fleshing out an actual driver that revolves around this so we have better control over it. That was literally 200 pulses. Holy cow, that was fast. Well, which makes sense. So let's see here. To add another. Let's just send that to 2,000. Oh no, little troublemaker! Come on, I know you want to say hi. Yeah, you can probably hear her on the mic. And I'm fine with her being down here because she's an oldie. She's like 15 years old. My little girl. Got some health problems, but we're doing what we can for her. Okay, I mean, that would work. That would literally work. It's just, this is gonna, yeah. It would take really fleshing out this driver, really spending a lot of time with this driver and actually doing something with it. Because basically we'd have to take the frequency we basically want to run it at. So stepper motors, I'd have to get the specs on these particular motors, but we'd have to get the number of steps per full rotation. To fully calculate all this out is going to involve a literal ton of math, because we'll need the number of steps per rotation to understand RPM. We'll need to know the deflection angle and all that. Not to mention the size of the gear and everything like that. And then to figure out frequency, we have to figure out our period, which we would figure out for our pulses and microseconds. So we'd have to set up our pulses. So right here, this would be the pulse, and then this is the number of pulses. So we have to figure out all that, figure out all the math, and do all the calculations, and then take into consideration the microstepping. So we could be looking at a major stepper motor driver, right? And I'm not opposed to that, but right now that is not what I'm trying to accomplish. Maybe we will spend time fleshing that out in the future. Because what I'm planning on doing, once we get, once we're happy and we're ready to spin version 2, and I could get a version 2 board built, we can use like this old version 1 for some further prototyping and programming and testing, while I can let the version 2 do some more, operating and doing other things, have it running this test fixture, just to keep pushing it, just see, its longevity and stuff. So right now, we're not gonna sit here and write a very complicated stepper driver. We'll just use this driver. It works. So we know we have our default pins. We know it works. So 1 step reset. We're going to put that in reset. Step direction. 0, I think, is what counterclockwise on that thing. So 1 would be clockwise. The microstepping, we'll leave those alone. These are basically the defaults. Let's get that. I was just kind of looking into some things. So we don't need to expose. Okay, we don't need to expose any of these to the outside world. So what we need to do then is to figure out what we want to expose. We definitely know we need to do enable, reset, direction, and have systems in here handle that. And then we're going to need to figure out, like, I may have to figure that out, but we'll need to figure out, like, the commands to send to it to, change direction, things like that. So hopefully it's... What are you doing back there, little girl? You crazy little cat. You crazy little girl. Yeah. All right. I mean, you could stay up here. I was okay with it. All right. So let's start fleshing that out so we can put it in here. So, all right. For the dry, that's the duty cycle. All right. Okay. Because oddly enough, if we control that, so let's set that to 1. Build it. Oop. Oh, that's so cool. I think we can do a lot with that other driver for this, but we'll worry, like I said, we'll worry about that later. But then again, this would actually work out pretty well. So mind you, that's set to a duty cycle of 1. So one of the things I also did is I increased the resolution to, what was it? 8 bits from 4 bits. So they gave us a little bit more leeway to play with. And now you're going to make a fool of me. What the world are you doing? Oh. Punch myself in the face one of these days, I swear. Maybe a duty cycle of 1 is too low for this guy. Oh, I know what I did. Okay, that was my bad. Yeah, I'm going to punch myself in the face. I forgot that I went in here and I set the defaults to basically not enable the motor and to... Oh, my God. Okay. Shoot me now. All right. Okay. Oh. Okay. Step reset. Oh, we need stepper direction. All right. So the big thing I want to do now is to be able to run this for a more extended period of time, actually trying to do something, like run this gantry in repetitive steps, just to see how she runs. All right. So we know we have that. All right, so we're going to need some, these don't return anything. Let's see, stop. Nope, it doesn't return anything. Eight, 2, 5. All right. So reset would be functions that come in. We'll see. We may not use those. We may use them. Okay. Maybe. Okay. And yes, we could combine a bunch of these into one command. And maybe we will. But let's see what kind of chaos we can cause here. So, come in here. All right, so for prototypes, void because they don't return anything. We know that function works. Oops, wanted to find that twice. All right, stomp. So what we need to do then is that level. Let's see, STP enable. One because it's active low. So reset. You know what? Let's kind of combine those. Let's get rid of that reset. Don't need it. move this above the other one. Not like it matters, but hey. 0. The nice thing about this is as an example, that's why I might just leave this on here and worry about a more complicated one for my own projects. As at the end of the day, this will still work. And another reason I'm doing this is this way is it'll give you a clear understanding how the firmware works. Falls back into what I was complaining about earlier. So, oh yeah. Step. DIR. DIR. Okay. And STP duty. Huh? Don't tell me I got that completely weird. STP duty, yeah. Ah. Oh. All right, here we go. Duty. And I think what we'll want it to do is when we do that, init, clear that. All right, so I'm just going to make sure it builds. 35. 10. Hmm. Okay, I don't care saying, oh, that's not even being used. That's fine. All right, so it builds. Perfect, perfect, perfect. All right, so we should have a bold travel direction. All right. So this is going to go back and forth. Okay. So what we're going to do is, even though we have some defaults, let's come over here. Let's just go ahead and I think we're, what are we doing? We have just stopped. Even though by default, we don't want any weird code catching through. So, okay. So we live that. It's an error flag. So here we go. All right. So we need to set up our logic here. If status is not equal 1, all right. So side motor stepper is CW rotation or dir of 1. So if it's going that way, all right. So basically we want, if the left side is hit, because our default, so stepper 0 would be counterclockwise, which would mean the gantry is moving towards the right. Hits that would go down. So we're going to go. First thing we need to do, just need to stop. We need to yeah. Travel direction equals 1. Direction. Okay. Let's see what this does. Direction equals 0. Oh. Now, mind you, this doesn't catch accidental inputs. So let's build it. Oh. I already see something I forgot. Oh, stop, start, okay. Okay, so if that, wait a minute here, well. There we go. Stop. Start. Okay, so if we have that, enable is good. So where are we going to start it? Enable. You know what? Is operating. All right. If zero, okay, set that flag so it's operating. And then down here, see, outside the loop. No. So if okay, so right here. Control 1 status. Equals 0. If it was operating equals 1. Equals 0. All right, so it should give us everything we need. Let's try it. No, are you missing? 100. My bad. Should fix it. That's the truth. All right. Whee! Let's flash this sucker and let's see what we got. Let's see if we have chaos. Okay. Oh yeah. Really slow. So it thinks it's traveling this way. It's going to travel this way. Oh, we need to... Okay, so we need to fix our logic, because what will happen is it'll hit the switch, but it won't automatically go the other way. So we might need to change our logic there. But hey, the enable button works, so we can shut it up for now. Okay. Okay. Okay, so let's fix our logic. Okay. Hmm. We want it to be able to smack that. But we don't want to hold into this. So let's do another conditional check here. If there we go. We'll get a conditional check here. Do that. Get the other equal sign in there. Else get mad at me again. So what this should do is fix it. All right. Build it. Are you kidding me? $119. Oh. Caps lock. Caps lock got me. Flash you. Okay. Oh. There we go. So now it's not stopping. It's I guess that's fine that it won't start again after both limit switches are hit. Because that would be a serious fault condition. You don't, and if it goes into a fault condition, you don't want it to like just decide to start working on its own. So it does look like okay. We are matching the rotation of the motor with the limit switches. Turn that guy off. And now let's get the motor connected back up and let's get this gantry moving. Because that's one of the things I know I've been waiting to see. We'll see how that does. All right. We have gantry motion. It's a snail's pace. But it's moving. All right. And it should ignore that limit switch. Even though it's traveling in this direction, it should ignore it. So the cool thing is we've already proved that the belt does drive. It does work, this TPU printed belt. Excuse me. Ooh! That's a little slow. Let's bring up the duty cycle a little bit. All right. So we have our default. We can change this later. Let's go to 2. And we can set it up in the console, the RS-485 console, which we might do real quick. We have a couple more minutes, but I want to flash this over. Oh. Let's make sure. Okay. So now we got some more speed. Put some weight on this guy here. Just so you can see what's in here. Here. Yeah. Keychain stuff. Yeah, getting a little bit of lag, motion lag off of my phone, but I'm not going to cry about it too much. Because honestly, in real time, in real life, it's nice and smooth. There's no jagger or anything. It's just clickety click, 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 click. So that is looking sweet. So let's go into, let that just go on its own over here. RS45.C. So what we want to do then is we want to include all right. How do I do that? I gotta did it in here. Let me see here. Here, let's just all right, PWM fan H. No. Dot DRV. Okay, so now we go down here. So I have a token here. Fan set. Okay, so we have to grab the argument out of there. So I'm just going to copy this. Come in here. I put that underneath the... put it underneath the help argument. So we're going to change this. Got the motor. Stepper, motor speed. Int. Motor speed. Oddly enough, so 10 seems to have been the limit for this. During some testing, it cranked it up pretty high, and I don't want to go anything above that. Motor. Zero and 10. It's an error. We don't want it to do anything. So, what is the command over here? Okay, we're going to copy this. And that is going to be motor speed. Motor speed. Rs45 send. Rs45 send. Okay, response. I don't know why it's. So what that do? What would that do? Comes over here. So should be able to set a speed. We set actually oh crap. All right, I messed that up. I didn't grab the all right. Motor speed. All right, there we go. Okay. So we send a command through the RS45. Let's get this guy going. Oh, crud. Device manager. I know I've got it turned on. I just can never. Tom 24. All right, there we go. And I think I've got in here. Just a little helper. Motor speed. The 10. All right. So. All right. Where are you mad at? Oh. Response undeclared. What am I missing out of here? Did I not? Oh. Okay. Char response. Huh. Sometimes it gets mad. Oh. I see what I did wrong. Blop. There's mad at. That's what should have been mad at me. Oh gosh, why are you broken? Oh. Oh. Yes. All right. All right. Okay, so we have that. Let's go ahead and flash you over. So we should have this. Okay. Reset that guy. We do a help. Motor speed 0 to 10. All right. Okay. Okay. So we enable this. Okay. 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 Okay, I have to figure out why it's giving it that weird variable at 10%. It's like it's mapping it, but so yeah. So I could send the that's 1. Really grinds it down to a crawl. 5. It seems to be as fast as we can go with our current settings. So. But here's the positive. It's working. I'm not really too hyped up on looks like there's no difference between 1 and 2. It only has like 2 speeds. Maybe we have to actually give it a higher value. Maybe we have to just go to 100. Let's find out. All right. Let's build this. Turn this guy off. Maybe we do need to go higher for it to work, because it is only 8-bit. Let's see what she does. So that should be 2. Okay. 50? No. Changing the duty cycle is not doing anything. No, duty cycle's not doing anything, so I think we're tapped out with what we can do with this driver. All right. All right. Now, 2 more commands. We not going to throw any more commands in there yet. That's fine. That's all we really need. It's actually all I really wanted for now. Because we might do the... Okay, so... but we've got it moving, and this is the one of the biggest things. I'm actually really happy. Honestly, I'm kind of impressed that I know it's not super high speed, but that TPU belt is actually working, and it's driving the carriage. And it's actually got quite a bit of grab. If I try to hold it in place, it drags the whole fixture. That's impressive. That is actually that is like low key impressive right there. I mean, it just so that's like, you know, this is next to it weighs a little bit. That thing is not light by any means. And I'm trying to hold on to the gantry. It actually drags, it actually moves the test fixture. So I am actually impressed with this, with that TPU belt thus far. Now, we might be able to see if we can push up the speed a little bit. You know what, let's kind of play around with some values here. Let's see if we can kind of come over here to the C file. Let's kind of increase the frequency. Let's go to 8,000. Let's go to 10,000 hertz. Because then with the higher resolution. Oh, I wasn't waiting. Flash. I didn't give it long enough to finish doing what it was doing. Okay, we're done. Okay, so now that's the higher frequency and the duty of oh, there we go. There we go. We got. Okay, so I increased the frequency. Now we're getting somewhere. Okay, that is at 1. It's too low of a duty cycle for it to run. Okay. Motor speed 2 is enough for it to run. It sounds like crap. That's it. 3, you can hear it. 4, smooths out. 5. Okay. Seems like that's yeah, even 100% speed. So let's try changing that to 20,000 hertz. Let's see here. Will it run at 12-bit? We will find out if I make it mad. Give us a little bit more resolution, higher frequency. It might not like it, but hey. We will see. Okay. Enable. Okay, that's the lowest duty cycle. Motor speed. Yeah. Yep. So one of the so let's leave at that frequency, but let's go back down to 8-bit. Build it. That's another reason fleshing out a better driver might be better in the long run. We might be able to get better speed control over it. And we probably will. Who knows? We'll see what we can do. All right. I don't think it likes the speed mode that we're in, but... Oh, there we go. That's 5. Yeah, we've definitely got some more action. So I increased the frequency. Let's see if we still have that's definitely moving at a pretty good clip. Yeah, it wants to jump. Which is good. We don't need anything that fast anyway. Let's go back down to 10,000 hertz. Because there's a happy medium. It's not running it too fast, too crazy. And it's fine for what we are using this for, to basically run the stepper motor. It's more than enough, because there's still a lot of other things I want to kind of code and put together for this. Here we go. when they get, basically some of the other sub modules written so that they can interface and talk with each other. Like the temperature sensor, get that working. That's fine. Yeah, for like a durability, an operational test of this, that's more than enough. And then, perfect. Okay, yeah, that's fine. I am not. Yeah, so the not the east stops, the limit switches. If so, here's another test I may regret. Yep. So if they come disconnected, it automatically stops. That's exactly what I wanted it to do. Perfect. Or if that common comes undone. Perfect. So, okay. So that'll reset it too. Okay. All right. All right. So I'm not going to keep this running for now. Oh, the thing is fun to watch. Mainly because I want to get the cycle counter put in into the code. So that every time limit 1 clicks. So don't need that right now. Don't need this right now. Don't need this or this. So basically every time this happens, it changes directions. Either one of these, it will increment a counter. That way we can keep track of total cycles, left to right traversals, right to left. Basically, how many traversal cycles it's successfully completed. That's another reason I want to get this pushed far enough. Pardon me. That way we can make any last minute revisions to the board and get version 2 spun and tested and get it kind of built up and put into the test fixture, and to kind of run this as a more longevity test of the second revision. But this is good. But like I said, we got a couple more modules to throw in. Temperature sensing, cycle counter, throw in the RS-45 console to be able to read the cycle counter, and to go from there. I say this is progress. We've got a stepper motor and a system moving and driving. The test fixture is operational as far as I'm concerned right now. So I'm happy. So I thank you for tuning in and hanging out with me while we worked on this. And I really appreciate it. And see, it's Monday, so I should be streaming Wednesday evening around 6, where we'll pick up where we left off and start coding the other modules and testing them and getting them integrated, so everything will work. So thanks for hanging out, and I will catch you later.